Hello, I'm Imran. In this video, I'm going to explain my project on SAS Enterprise Miner. As you can see here, I've already created a project called Wine Project. I'm going to select my Wine project here. As you can see here, I have already created a diagram called Wine Data Diagram. Use these nodes for my project: File Import, Statistical Explorer, and Data Partition and Decision Tree. I have taken the wine data from the UCI machine learning repository. I have attributes like fixed acidity, volatile acidity, citric acid, chlorides, density and pH, and using all these input variables I am going to predict the output variable, which is quality of the wine and which has a score between 0 and 10. On the wine data, I have two types of wine data. One is white and one is red. So for this I have also added one more column from the data set. I have added one more column called color, which is white or red, and except this, all the other values in the variables are numeric. So I have imported my data from here, imported from import file here. And after importing file, I can see the variables here. Here, except the quality of the wine data, all the other variables are input variables. And here I have the option to drop any variable which I am not interested in. As you can see here, all the variables are either interval or nominal. Only one variable is nominal here. If you want to see or explore these data, we can select all these variables and click the explore button. As you can see here, all the variables are given as a bar representation here. If I select the color as red, all the associated values for the other variables can be seen here, like what are the pH of red wine, and what is the quality of the red wine, in which categories they fall under. Similarly, if we press this white wine, we can see the associated values in all the other variables. This will give a better understanding of our data. After this, I have kept the Statistical Explorer node. We can see here the results of our Statistical Explorer node. Here we can see the minimum, maximum, median standard deviation of all the variables from our data, and how much data we have, and how many variables we have. We can always see here. And after that, I have partitioned my data into training, validation, and test set. I have given values like 70, 10, 20, and 10. So I want to partition my data now. You can see here the number of instances for training, validation, and test set. Total I have 6,497 instances, and these are divided into 4,500, 1,200, and 650. And for each training, validation, test set, you can see all the number of observations and minimum, maximum values for each variable. After that, I have created one decision tree model. Using this decision tree, will divide or partition the data depending upon the variables and split the data into two. Here I have also mentioned the leaf size, number of rules, split size, and we can vary this according to our priority and need. So I'm running this node. Here we can see the tree structure of our data. Here this is the main data, and this is split by alcohol variable. Alcohol percentage of greater than or equal to 10 is split into right node, and the rest are split into left node. And these are again split by volatile acidity, and these nodes are split until we cannot split furthermore. And Here, as you can see, there are a lot of leaves here. We can also see the tree map here. This is what we have seen in the other diagram. This is our main data, and this is split into two. Again, this right node is again split into two. This gives a pictorial representation and the number of instances in each split. And you can even see the average for the training and validation data sets. And if you want to, we can see here, as we can see here, the average square error for the training and validation data sets. Here for the training data set, as the number of leaves increases, the average square error has gone down, but for the validation data set, it has become constant after a certain number of leaves. That means we are after splitting the data from 19 leaves to 34 leaves, we are trying to overfit here, and we can always see the sum of squared errors, mean absolute error. This will give how our model is performing. So about my project on Science Enterprise Miner. Thank you.